Hey, welcome back. I'm Sean Barn at Looking Point. We help IT organizations make decisions around collaboration, security, and networking. Today we're going to be talking about how does a switch actually switch. Let's go! All right, we're back and we're talking about how switches actually switch. So before I jump into the actual process of how switches switch, let's cover a couple terms. So the first thing is a MAC address. So MAC address is burned into every single network device or every single network port of a device that's going on a network. That MAC address is the physical address of the actual card in the device. So when it connects on the network, it has a unique address that is associated to it. That is the MAC address. So MAC address operates at the layer 2 layer or the data link layer of the OSI model. And so when we're talking about how a switch works or operates, it's very important to understand what a MAC address is and that it's burned into every single network device or every device that connects to the network. So now that we know what the MAC address is, let's talk about how a switch switches and why it's called a switch. And mainly it's because if you are on the same layer 2 network or the same layer 2 broadcast domain, traditionally, if you were talking host to host, all of those other devices on that same layer 2 segment would see the traffic. Well, what a switch does is it isolates host-to-host communication by switching it. And how it does that is it builds something called a CAM table. And really a CAM table is just a list of MAC addresses associated to the corresponding port. And so what that means is if I have a host that's connected to port 1, and let's just say this isn't a valid MAC address, but I'll just say it's MAC 1 for host 1, and I have another host 2, and its MAC is MAC 2, and I have a third host which is its MAC is MAC 3. If host 1 and 3 are talking together, the first thing that the host 1 is going to do is it's going to ARP if they're on the same layer 2 broadcast domain. They're in the same layer 3 network. They're going to ARP for the other device. And an ARP is basically a request saying, hey, I need to talk to you according to my IP address and subnet mask. You're on the same network as I am. So can you tell me your MAC address? And when it sends that ARP request, it's sent out with a broadcast layer 2 MAC address. And so the switch sees a broadcast MAC and floods it to every single port in that VLAN. And what happens is as soon as that host sends that ARP request, the CAM table is built for that port and that host. And so what does that mean? Well, it now knows that MAC 1 is connected to port 1. It doesn't know anything else at this point because we're just starting a theoretical example. And then port 2 and port 3 see that. And port 2 says, is this IP address, the one that's getting the ARP request, is that my IP address? It goes, no, so it doesn't say anything. Host 3 gets the ARP request and says, oh, that is my IP address, and responds back. And as soon as it responds, the switch then sees its source MAC address for host 3 and says, MAC 3 is on port 3, how convenient. And now it knows host 1 and host 3, their MAC address and their associated ports. That information gets back to host 1 and it says, okay, if you want to talk to me, here's my MAC address, it's MAC 3. And then what it starts to do is put MAC 3 as the destination MAC and the source MAC is MAC 1. And the IP addresses, I wasn't really talking about the IP address, but the source and destination IP would be mapped corresponding. Source would be host 1, destination would be host 3. As soon as the switch sees that packet, instead of flooding it out all ports like the request did, the ARP request, it's going to say, hey, MAC 3 goes to port 3. I'm just going to send it right out port 3 and not bother anybody else on this switch. And that happens hundreds, thousands of times through the actual switch. So basically what I described is how a switch builds its CAM table, and then once it builds its CAM table, or once it knows where all these hosts exist, it starts sending destination traffic for a specific MAC right to that port and doesn't bother anybody else in the network. And so that allows that network to be much more efficient and much more effective at passing traffic, especially when we talk about host to host. And so that hopefully sums up in a very basic way how a switch operates at layer 2, how it builds its CAM table, and how it sends and manages traffic. Before I end the video, I'm going to give a few extra little tips. So some of the issues that can happen is CAM table space is very important. So in large switching environments, maybe you could have a CAM table issue where you have maybe a core switch and it has a bunch of other switches connected off of it. It's going to build that CAM table. Instead of having one MAC to one port, it may have multiple MACs to one port. And so what that is going to do is require a lot of CAM table space to store that database of all these MACs to ports. And so if the CAM table overflows or it runs out of space, the switch no longer says, I can't store all this information. I got to forward it out of all ports. I got to go back to the old way. And that will severely degrade switching performance. So if you're troubleshooting a network and you're starting to see intermittent performance, and it's really a large campus or a switching environment, and you're seeing some of those types of things, I would be checking the CAM table. Make sure you've got good information, good space in there, and make sure that your source and destination MACs actually have a destination port so it's not flooding out all ports, because when switches start acting like hubs, you're going to get network problems. I hope this helps if you're thinking about, hey, how does a switch actually work? You're getting you're new into networking. You want to know more about it. I hope this helps. If I said anything in this video that you're like, hey, love to know more about that, make sure you leave a comment. Make sure you like and subscribe so you get all of our content as we release it. We'll see you on the next one. Thanks for watching.